Hello, my name is Ishant Chatterjee and welcome to my Leetcode Problem video. Today we're going to look at a problem called longest substring without repeating characters. We're going to look at the problem description, see an example, and then we're going to look at two solutions, the sliding window solution and the optimized sliding window solution. For each solution, we're going to see an explanation, an example, the code, and finally analyze the time complexity. You are given a string and you are tasked on finding the length of the longest substring that doesn't contain any duplicates. In this example, you're given the string ABC, ABC, BB. And the longest substring without any repeating characters is ABC, so return the length of ABC, which is 3. First solution we're going to look at is a sliding window solution. At every point, you keep track of the current substring you're on, and at every character, you check if the character is in the substring. If it is, you move the beginning of the substring forward until the character is not in the substring. At the end of every iteration, you add the current character to the substring. And finally, at the end, you return the max length that you found. So, in this example, you're given the string ABC BDE. So first we add the first letter, which is A, to our substring. Then we add B and C. And then we reach B. And since B is already part of our substring, we move the first, or the beginning of the substring, until B is not present, twice. Now that B only occurs once, we can go forward again, and we add D and E. The largest substring we witnessed is length 4. We have our driver method. Then instead of keeping track of a string for our substring, it's faster if we use a list of characters and a set of characters. The list will be used to see which order the characters are in, and the set will be used to check if there are duplicates. Next, we convert the string to a character array for convenience, keep track of the length of the current substring, and the maximum substring. Now we iterate over the array, and if the set contains the current character, we update the maximum variable, and then while the set contains it, we remove the first letter from the substring. Finally, we add the current character to the set, the list, and update the current variable. Finally, at the end, we return the maximum of the current and the max in case the current went past the max. Since we iterate over the array once normally, and we move the beginning of the substring by a maximum of n, the time complexity is worst case O of 2n or O of n. The next solution is a sliding window optimized solution. This solution is the same as the sliding window solution, except we don't keep on advancing the beginning of the substring. Instead, we keep a map where we store the indices of every letter. So, when we find a duplicate, instead of going forward until the duplicate is not present, we just look up the index of the duplicate. So in this example, we add A, B, and C. And now that we reached B, we know that the index of the previous B is at 1, since we stored that in a map. And we can simply cut off all of the letters before that. And we keep the maximum as 3, since the length of the substring at that point was 3. Now we move on again and find a substring of length 4, so we update the maximum for length 4. We have our driver method, and then I create a map of size 0xFF, which is 256. 256 is the amount of possible characters there can be. I'm using an array instead of a hash map for fast lookup in exchange for more memory space. Next, I keep the maximum variable for the maximum substring and the current variable, which is the length of the current substring. I convert the string to a character array for convenience, and finally fill the map with negative ones. Now we iterate over the array, and if the map at cars I is greater than or equal to 0, which means if we have encountered this letter before, then we update the maximum. Then we set the index of our current letter to I. Next, we update the maximum according to the current. And finally, we return the maximum. The time complexity is O of n since we iterate over the array once. And that is it. Thank you for listening, and I hope you enjoyed.